So hopefully you are convinced that we are perturbing the climate and there are already many impacts being seen. We will see some more specific impacts as we go forward. Or you have learned enough about the science that you can be skeptical, which means you can ask questions, legitimate questions about things that you don't understand or don't believe. There's a difference between being a denier or cynical as opposed to being skeptical. Skepticism is the foundation of science. We ask questions and we try to answer questions. We try to find evidence to answer the questions that we raise, right? Remember, data, hypothesis, more data, theory, and so on. So that's what you have to be able to do by learning these things, to be skeptical, ask questions. Okay. So if we know that we are emitting greenhouse gases which are perturbing the climate and many of the impacts are going to be bad, we are trying to navigate into the future by trying to minimize our impact on the climate and reduce the harmful effects. Correct? This is being done, as I said, under this IPCC, Intergovernmental Panel on Climate Change, set up under the UN Framework Convention on Climate Change, UNFCCC. The same group of scientists, now combined with social scientists and so on, produce scenarios for the future. There are lots of details involved, and the way the scenarios are developed has changed over time. So now, right now, for the report that was put out in 2014 and the report that is coming out in 2021, this is the way it was done. So we develop scenarios. So we are going here, let's say, from 2000 into 2100. 2100 is kind of the first horizon that had been looked at for long-term climate change, but as we saw, some of them go into 2300 as well. And you can see that there are multiple lines here, with some going to emissions of 30 gigatons carbon, and there are bands here showing the uncertainties in these future scenarios. And there are some that turn around and start dropping down to zero. Zero emissions. Wouldn't that be fantastic? Well, it turns out that if we want to control the situation, we may in fact need to completely decarbonize. In fact, it seems like if you read all the relevant literature, I have talks on YouTube you can look up, we will need to reduce carbon emissions to zero. It's fuel efficiency, reducing emissions and so on is probably not going to be enough. We just have to completely decarbonize, and these are the scenarios that go for it. But there are others that reduce emissions and so on. That corresponds to CO2 concentrations. So obviously this high emission scenario goes up, takes the CO2 concentration heading straight towards 1000 ppm, which happened 65 million years ago. By the way, that drop from 1000 ppm 65 million years ago to the present, remember we had a long-term cooling over 50 million years as well, is potentially related. One of the best theories we have by Maureen Ramo is that the Himalayas formed, monsoon happened, as new mountains formed, lots of buried material got exposed, and the monsoon started to take down that sediments into the rivers. Even now, as I mentioned before in one of the podcasts, the rivers that come into the Indian Ocean from Himalayan origins have the highest sediment loads in the world. So they were potentially also related to drawing down the carbon and bringing it from 1000 ppm through the several ice ages down to 280 ppm before the beginning of the Industrial Revolution. Okay, there we are. Anyway, so CO2 can go very high in the worst case scenario where you do nothing almost. It's called business as usual, so you just say we don't care. And then there are other scenarios. The drawdown here is the lowest one. These terminologies here, RCP 2.6, 4.5, 6, and 8.5, correspond to the so-called representative concentration pathways. So these are the representative concentration pathways. What are the numbers 2.6, 4.5, 6 and 8.5? These are the perturbation to the radiative forcing, the net imbalance at the top of the atmosphere. So how much additional energy is being trapped by these various emission scenarios. Okay, the scenario is not just one line, it has a band around it, which means it has a range of possibilities which are determined by changing various things like population increase, technologies, renewable energy sources, human behavior changes, policies to reduce emissions, and so on and so forth. There are hundreds of scenarios that go into each emission pathway. So this is the radiative forcing, 2.6 watts per meter squared excess, 4.5, 6 and 8.5 watts per meter squared excess forcing. Okay, so the last set of models, IPCC models, under the so-called climate model intercomparison project, which means each country produces several climate models. India has its first full Earth system model, which participated in the 2021 report, so its results will go there. China has 5 or 6 models, US has 3 or 4 models, Europe has a bunch of models, and so on. Australia has models, etc. South America has models, right? So you take all those models and you look at how well they are doing in reproducing the 20th century. So here is where detection attribution comes back. So in the detection and attribution here, you want to show that this warming in the 20th century, since the Industrial Revolution is related to the greenhouse gas emissions, so you run the model. Remember, in the model you can move the continents, you can change the concentration of greenhouse gases, you can change the amount of energy coming in. So it's like a toy where you can make many scenarios, right? That's important because for the future we are making scenarios with these models, but you have to be convinced that these models actually work. So you do that by recreating the 20th century warming, and you can see that all the models are reproducing the observed warming with various differences among them. Nonetheless, 42 historic models produce the historical simulations, and we are convinced that they are able to do certain things. And this is amazing, 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 because you put the model has an atmosphere, as we saw, has a cryosphere, has biosphere, has geosphere, has ocean, has sea ice, etc. You just give it energy at the top of the atmosphere. It takes that energy, it produces the equator to pole temperature gradient, it produces Walker cell, Hadley cell, monsoons, El Niños, thermohaline circulation, everything. And you increase greenhouse gases, it produces the warming. So you can take out the greenhouse warming and show that greenhouse gases, and show that if we didn't put in the greenhouse gases, there would be no warming. That's attribution. So we detect the warming and use a model to say if we somehow had magically done all this economic growth without putting in greenhouse gases, there would have been no warming. That's attribution. We detected a change using a model. We showed that the warming can be directly attributed to increasing greenhouse gases. So where are we headed into the future? Depending on whether it's RCP 8.5, 6, 4.5, 2.6, here are the number of models that produce the simulations for these carbon emission pathways, and you can see that the warming ranges from as high as 5 down to about 1 degree. So then this also allows you to say, if I want to keep a warming only at a maximum of 2 degrees, then what is the carbon pathway that will get me there? What are the technologies I will need to control the carbon emission pathway to get there and to stay in this emission pathway? That's how these future scenarios are used. It's complicated business, but this is just an introduction. It's a basic course. So you will have to do the work to go back and do more research if you're interested to understand the details of what models are used to produce these scenarios and pathways, and what are the details of the assumptions made into the future. Remember, as Yogi Berra. If you don't know who Yogi Berra is, he was a famous baseball player, and he used to say bizarre things, but then many bizarre things got attributed to him along the way. He said, prediction is really difficult, especially about the future. Okay, prediction is always about the future. Nonetheless, making future scenarios is not easy, but it is something we must do despite the uncertainties in there. It's a guidance for making decisions collectively to avoid disaster.